Okay, so let's get started on section 3.1, exploring side angle relationships in acute triangles. So before I talk about what that means, I want to go over this little section here where it says tip. It tells you about labeling triangles, okay? It says if the vertices or angles of a triangle are labeled, for example, A, B, and C, then the sides of the triangle are generally labeled A, B, and C to match, but those letters are in lowercase, and that's on purpose. So side A is the side opposite angle A, and so on, okay? So they've got this picture going on with triangle A, B, C. Capital letters are angles, and lowercase letter are side length, okay? So notice capital A, angle, is across from small a, which stands for the length of BC. Capital B is the angle measure here, and that's across from small side B, which is the same as AC. So B stands for the length of the side. Capital C stands for the measure of this angle. Small side C, right across from it, stands for the length of this side. Okay? Now that's important because now we're going to talk about the sine ratio. Okay, so this is also called the sine law. And I'll probably say the sine law so that you know what I'm talking about. So here it says keep in mind that the ratios of the length of opposite side divided by the sine of an angle are equivalent for all three side angle pairs in an acute triangle. Okay, so let me just show you what that means. Let's say, I'll pretend I could draw more beans. Let's say that this is triangle MNO, for example. Okay. This is angle M right here, the measure of it. This is angle N, and this is angle O. If this is angle M, this length here is small side M. If this is angle N, this is small side N. And if this is angle O, this is small side O. So if we go up here to the ratio, it says the ratios of the length of the opposite side divided by the sine of the angle is equivalent for all of the sets. So according to this triangle I just made up, I could say that the length of M over the sine of angle M is equal to the length of N over the sine of N. Okay, so the length of the opposite side divided by the sine of the angle. I could say that the length of M over the sine of M is the same as the length of O over the sine of O, because they're all in the same triangle. And then I could also say that the length of N over the sine of N is the same as O over the sine of O. So any two sets will work in the sine law. So I could say this divided by that. I could say this divided by that, or the last one. Okay? So it's important to be able to set these up because you can use them to solve problems. So example number 1 says, given that A, and it's a small a, so it means the length of side A. So given that small a over the sine of 30 equals 13 divided by the sine of 70, sketch the triangle for this situation and then determine A to 1 decimal place. So let's sketch an acute angle triangle. And the only letter I've been given is A. So I'll just say this is side A. It doesn't really matter which one. But if I say that's A, this is the angle opposite it. So if that is small side A, this has to be 30 because they always are in sets. And then it says equals 13 over the sine of 70. Okay, so let's call this side 13. The top one is always the side length. And if that's 13, this has to be 70. Okay, and this would have to be angle A because small side A would be across from big angle A. And then I don't have any other letters, so I can't really label anything else. But it asks me to determine A to 1 decimal place. So they've already set up the ratio for you up here. It says A over the sine of 30 equals 13 over the sine of 70. And anytime you have a fraction equals a fraction, you're allowed to cross multiply. And cross multiply means that the value of this times that, so the value of a times the sine of 70 equals this times that, equals 13 times the sine of 30. Now it's important to put the sine of 70 in brackets because you want to make sure that you're taking the sine of 30. That's a decimal number and it's not 30 times 13 and then find the sine of it. Okay, so here's my unknown. A is the thing I want to find out. Okay, this is what I'm trying to find out. It's being multiplied by the sine of 70. So to get A by itself, you're just going to use algebra. To get A by itself, divide by the sine of 70. Because that will allow that to cross out. But whatever you do to one side, you have to do to the other. Okay, so AL by itself will be 13 times the sine of 30 divided by the sine of 70. So I actually found this cool online calculator. It's web2.0calc.com. If you want and you don't have a calculator, you could use it. So we are going to take 13, we're going to multiply it by the sine of 30 and divide it by the sine of 70. So on this online calculator, or use the calculator you have, take 13, we're going to multiply it by the sine of 30. Make sure you always close that bracket, and then at this point, press enter. So that's 13 times the sine of 30, and I'm going to divide it by the sine of 70. And as you can see up here, 6.917155, on and on. It asks to one decimal place. So A, my pen down here, is 6.9. Now you should just take a quick look, does that make sense? Okay, so across from my 70 was 13, so across from my 30 has to be smaller. 30 is smaller than 70, so this across from the bigger angle will be a bigger side, and 6.9 is smaller than 13, so that makes sense. And so you should always just take a quick peek and see, does a smaller angle create a smaller side, which of course it does. Okay, so when you want a side length, you set up your ratio and solve for the unknown. Example number 2 is not a side length, it's an angle measure. It's asking for angle A. Okay, so the question said, determine angle A to the nearest degree for this ratio. 20 over the sine of A equals 13 over the sine of 36. So again, because I have a fraction equals a fraction, I can cross multiply. I can say 20 times the sine of 36, 20 times the sine of 36 is the same as the sine of A times 13. Notice I always put my number first because I want to keep that side length separate from the angle. Okay? All right, so I have 20 times the sine of 36 equals 13 times the sine of A. Remember, angle A, this is my unknown. Okay, but it's right now it's saying the sine of A. So that's what I want to isolate. I'm going to divide both sides by 13 so that that will cancel. Whatever you do to one side, you have to do to the other. So right now I have the sine of A equals 20 times the sine of 36 divided by 13. So let's go to your calculator. Take 20, multiply by the sine of 36. I always press enter at this point, and then divided by 13. So 20 times the sine of 36 divided by 13 is 0.904. So 0.904. Now it didn't ask for the sine of A, it asked for angle A. So hopefully you remember from Math 10 that anytime you want angles, you want angle A, you're going to have to take the inverse sine of that number. So on your calculator, you might have to go second function. On this online calculator, I'm going to go second sine. Okay, so I know on this graphing calculator it says a sine or it says arc sine, but here's that sine -1. It's the way that you tell your calculator, I know the ratio, I want the angle. Angles are always to whole numbers, so it says 64.7. Angles are always to the nearest degree, so I will say angle A is 65 degrees. Here's my answer. All right, get started on your work.